Hello, Professor. We will just take 5 minutes more time to start your presentation. So I'll give a short introduction about, and then you can start your lecture.
Yeah, okay, thank you.
Okay.
I will introduce by myself, or you will introduce me? Sorry?
Of course, I will make a very small introduction about you, and after that, if you want to introduction about yourself, you can do that.
Okay, I see. Can I start now?
Just let me complete first. I'll take only 2-3 minutes.
Yeah, okay.
Hello, good afternoon, everyone. So now we are going to start our second session, and the topic of the second session is deep learning approach for sentiment analysis. And our speaker is Professor Thanh. He is the director of Ethics and Artificial Intelligence Laboratory, and he received his MS and PhD degree from Japan Advanced Institute of Science and Technology in 2010 and 2013 respectively. He is currently the Director of Data Analytics and Artificial Intelligence Laboratory, Engineering Technology Faculty through the Mud University. His main research interests are natural language processing, machine learning, translation, text processing, data analytics, and artificial intelligence. So, hope all of you will hear the talk, the lecture. After the talk, we can, invite your question. So, you just post it in the chat box. Thank
Okay.
you all. Now, Professor you can start your lecture.
Okay. Thank you for your introduction. Good afternoon, everyone. Let me present my presentation. Okay. Good afternoon, everyone. Today, I would like to present with you our research about deep learning approach for sentiment analysis. I'm Bùi Thanh Hùng from the Data Analytics and Artificial Intelligence Laboratory and the Engineering Technology Faculty, Kusumo University. Here is my email address and my site. Uh, Here the content of my presentation. First, I will talk about introduction. Next, the approach. After that, I will give a methodology for sentiment analysis and some case study about my research. And lastly, I will give conclusion. Now, let's begin with the part one, introduction. As you know, uh, social network is affecting to our life, and you can see the Facebook, YouTube, Twitter, yeah, every social network. And from social network, we put everything to social network, and from that we can mining. How about we think about your life or some problem in we put in the social network or in the Google product search, when you find some item in the Google product search, you can see that the sentiment analysis of each picture. For example, for the picture, for picture, zoom, design, video, battery life, and screen. And we want to know how the customer think about the picture of the camera, and the businessman want to know what we focus on and what we think about this product. That's why sentiment analysis is popular not only in the research and as well as in the business. In the America election in the 4 years, you know that in this election, uh, the debate between Hillary Clinton and Donald Trump, and from that, if we know what the sentiment analysis of the voter, we can read how we strategy for this election. And for the sentiment analysis, by the Ackerman 1992, he divided the sentiment analysis to the six sentiment: biggest anger, sadness, happiness, fear, and surprise. However, in the by the research by Alex Martin 2014, he divided 22 compound present expression of emotion, and you can see in this slide. What is sentiment analysis? You know that sentiment analysis or opinion mining is a computational study of the opinion, sentiment, appraisal, and emotion. And sentiment analysis is important because you know that opinion are key influencing of our behavior, and the rate of the AI and chatbot shows that emotion and sentiment are key to human communication. This is from short overview of our sentiment analysis by Millennium Huang 2016. The problem is first because it electoral changeling and many applications. It just every aspect of LFP natural language processing, and is a major technology from natural language processing. However, this problem is hard. And the researcher has mainly stated sentiment analysis as the three level of granularity. The first is the document level, the second is sentence level, and the last is the aspect level. In the document level, we want to classify an opinionated document as expressing an overall positive or negative opinion. And in the sentence level, we classify individual sentence in a document. And how about the aspect level? This means that this extract and summarize people opinion expressed on entity and expect picture of entity. Here is a roadmap of sentiment analysis. You can see that in the spammer detection, sentiment retrieval, sentiment extraction, sentiment classification, sentiment summarization, or sentiment rating. So that you know that now you know how about the sentiment analysis, and you know that sentiment analysis is the popular and the most interesting, not in the business and as well as in the research. By the Russell 1980, he divide he used to the valence around emotion state. It means that we had the work here, and with if we use the state, you can divide the work to the state from the negative to positive, and from low to high, and from that this work we can divide the sentence report either negative or positive. Here to provide two approaches for the sentiment analysis. The first is a lexical based, and the second is the machine learning. In the lexical based, you can see that you can apply the characteristic of linguistic for the sentiment analysis. And for the machine learning, you will use the machine learning technique to classify the sentiment analysis. And here is the roadmap of sentiment analysis by Nguyen and Huang 2016. At the beginning, we use the lexicon, rule, and supervise. And from 2006 and 2010, we use SVM. GraphBase is almost a famous model for the sentiment analysis. And deep learning model, you know that from 2010, this is a famous model for sentiment analysis. How about publication? If we check on two types of popular publication, Springer and ScienceDirect, in 2018, with the keyword sentiment analysis, we can find that 3,900 publications related to sentiment analysis. And if we find the keyword opinion mining, we can find that the 600 publications related to this keyword. And in ScienceDirect 2018, sentiment analysis is the same with the in Springer, and opinion mining is 2,600. And for Vietnamese language, we studied for the Vietnam applied for Vietnamese language from the 2010. And how about the last year? Here I just checked in the last day, yesterday. This time from the 2019 to 2020. You can see that here is the result for sentiment analysis with the chapter, the article, conference paper. Yes, there are a lot related to sentiment analysis. And with the keyword opinion mining, you can see that here is the result with the chapter, article, conference paper. Yes. And how about ScienceDirect? ScienceDirect is with the keyword sentiment analysis in 2019. we can see that here result 4,303. One more research article is 3,000, and yeah, you can see this number. And for opinion mining, and we can find that 2,621 result. Yes, and you know that sentiment analysis is a popular and almost interesting in the natural language processing, and there are a lot of publications related to this subject. And here are some famous publications related to sentiment analysis. Yes, I just take a look. And here for the Vietnamese language. Yes. And how to solve the sentiment analysis problem? We can use many approaches, but in the first phase, you have to know about the work embedding. Work embedding, at the beginning, if we use machine learning, we use one hot vector, we use TF, IDF, we use backup work. But for the deep learning, we have to use the work embedding. There are many kinds of work embedding. By the Thomas Microvet 2018, they propose two kinds of work embedding: SIBO and SkipRAM. SIBO means that continuous backup work. SIBO. This model predicts from the present context base in the last couple column with a sliding window. For example, we can see that here we have sentence with sliding window with equal to, and from that we can predict the present. And if we see in the more detail how SIBO works, and we had the work cat and on cat, and here we have one hot vector for the work cat and one hot vector for the work on, and from one hot vector, if we give the magic, we can multiple and to get the V male V cat, and similarly we can get the V chain V on, and we will calculate the average of this vector, and we had the EY, and we will use this step many times to get the result as we hope, and from that we can calculate the work embedding of this work. You can know that for easily understanding, you can know that the work embedding, it means that the effect between work in the concept. Yes. For example, if you have the dictionary with the 100 words, and from that we know that the work embedding of each word, it means that the affection between the word in the context. And the second kind, proposed by Thomas Microvet in 2018, is the SkipRAM. SkipRAM is a convert with the SIBO. It means that this model predicts the context of the given target work in the last covered column with the sliding window. And another kind of work embedding is, you can see that is the global, fast stack, and burst. And I checked in yesterday. It's a SIBO. There are a lot of citations. Here for SIBO and SkipRAM is the same author, and global from the Stanford LMP research with this citation, and fast stack they give it two paper and show that this we can count from summary of this number with this number. And the birth was born in 2018 with this citation. Now we can focus more on the birth training of deep bidirectional transform for language understanding. Here is I checked in yesterday with logo and birth. Yes. With a lot of citation. Now we can discuss more detail about birth. How about the birth? Birth means that birth make you transform this attention mechanic that learn contextual relation between work or sub-work in the text. In its vanilla form, transformer includes two separate mechanics: an encoder that reads the text input and a decoder that produce a predict for the task. And here is a figure to show more detail about the bird. You can check more detail in this paper. And as an obstacle to directional model, with this the text input sequential left to right or right to left, the transformer encoder reads the entire sequence of work at once. Therefore, it is considered by directional. It would be more accurate. This characteristic allow the model to learn the context of the work based on all of its surrounding left or right of the work. Yes, and here you can see. And now you know how about the work embedding. Work embedding the importing picture for the deep learning model. Now we focus on deep learning approach for sentiment analysis. You know that artificial intelligence from the 1950 and machine learning is one method to solve many problems of artificial intelligence. And it was born in 1980, and deep learning was born in 2010. Is one main machine learning approach. In deep learning, there are many kinds of models. For example, FNN, feed forward neural network; RNN, recurrent neural network; or CNN, convolution neural network. And you know that there is scientists who kickstarted an AI revolution that Turing award. It looks like the Nobel for computer science. Yes, computer science. And they published in 2010. However, for the most popular scientific published in the Nature, they published in deep learning model for the Nature in 2015, and I checked in yesterday with this number for citation. Now we will move to the deep learning model. Look, but we know about the auto-encoder and denoising auto-encoder. This is a symbol model. You can see that here the relayer neutral network to set the target value to equal to the input value. Yes, the relayer. It means that auto-encoder and denoising auto-encoder. The symbol deep learning approach. And how about recurrent neural network? Recurrent neural network. This means that we can use the last picture for the next step or last readout for next step. Yes. However, it's a long step. We can do this more difficult to remember the picture or the result of the last step. That's why we have the long short-term memory. It's provided by co-creator at home to in 1997. In the INN, we have only one gate. You can see that here, one gate. We have only one gate, and with the long short-term memory, we have the four gate. Four gate. Yeah, FT. You can go zoom in FT. FT means that we use the last gate. Yeah, with the picture in this step. Yeah. And it in combination with the last step with the picture and addition with the bias, and you can get the result for this gate at T. IT is the same. IT means that we use in the last step. Yes. Yeah. And with the forget, we can remember or forget the picture or the last result in the last step to the next step. Yes. So that the long short-term memory is more advanced than the recurrent neural network. And you know that about the attention mechanic. This means that this model provided by the neuron 2014 for the attention mechanic. With the attention mechanic, we can focus on which the picture is the most impact to your result, and we can choose from picture to the next. How about the bidirectional LSTM? This model profile one around 2015. This means that we had the two long short-term memory with the forward and the backward, and with the combination forward and backward long short-term memory, we had a bidirectional LSTM. And we should talk about the first group, recurrent neural network. The second group is the convolutional neural network, CNN. CNN proposed by the Prisma in 1980 and improved by Lipun, Porto, Benzo, and Hafner in 1998. In the CNN, there are many layers, and the most layer in fact to the convolutional network is the convolutional layer, Mach-Turing layer, and Tunley-Connected layer. Here is the convolution layer. We have the kernel, this kernel, and here is the picture. And from picture, we can see the magic, and we use this. We can calculate to the small magic. Here we had the kernel with the 3D, and we had the picture with the 99, and 3, it means that we had 7. This picture is smaller than original picture. However, the picture keeps the most picture of the original picture, and we can process with the smaller picture easily. Yeah. So that is the convolution. You can know that this reduce the size of the picture, but the smaller picture keeps the most important picture in the original picture. And in the pooling, you can do the pooling. We had the picture with 7, and if we pooling 2. There are many kind of pooling, and the most impactful pooling, the Mach pooling. It means that we calculate the maximum number in this kernel, and we get and next this number, and and the last sorry, the second, uh, third, and the last. And from the picture with the 7 we can keep the picture smaller with the 4 size. Next is a relo to keep the outfitting for the process. And we had many kind of many methods for this step. And here is relo. Relo, it means that we can keep we can change the minus the number to 0. Yes, and keep the negative number. Positive, sorry, positive. Yeah. Negative we cover to 0. And the last step, the fully connected, it means that we, after the many steps, we can keep the picture smaller. For example, here we had a picture with the 3, and in this step we flatten this picture to get 9, 1. Yes, 1. And from the last step, we can get to the predict for the prediction. Yeah, is the CNN work. And in the CNN, there are many models in CNN. One model from the ILSBRC contest. Here, the model gets the first number or second number in this contest. For example, in 2015, that net is the first number, and in the 14 in the Google net, and BGD is the second. In the 13 in the 13, in the 12 AlecNet. Yes. Yeah. There are many models for the convolutional network. Yes. And you can know that this contest stopped in 2015, and you can see that the model is more complex than before. Yes. Yeah, here only 19 layer, but here is a 20 layer. Yes, here only 8 layer. Yes, you can check the internet on the internet with easily. How about the hybrid model? Hybrid model, it means that we will combine between the CNN and LSTM, or LSTM and CNN. And for the CNN work well in to check spotty picture. It's in the last step, LSTM work well than the CNN, so that it someday if you combine CNN and LSTM, we get a better result than only CNN or only LSTM. And the last model is reinforcement learning. Actually, you know, the reinforcement learning, it means that we have the agent and environment, and we can with the action with the reward, and from that we can get the action. Now the reinforcement learning is not popular for the sentiment analysis. Maybe it's suitable for another type of natural language processing. For sentiment analysis, I see that the few other apply reinforcement learning. And how about deep reinforcement learning? And in this step, we use the neural network here, and here the only reinforcement learning, and here is the deep reinforcement learning. And we know that what the difference between the deep reinforcement learning and reinforcement learning. As I told before, deep reinforcement learning is not popular for the sentiment analysis. It's work well for the robotic for another task of natural language processing. So that I not discuss more detail about this model. Yes, and from the deep learning for sentiment analysis, a survey by the Jiang et al. 2018, you can see that there are many kinds of deep learning model for the sentiment analysis. If we check in the document level, you can see that here, yes, with the work embedding and the neutral network model, use attention mechanics or not. Joint modeling with sentiment, yes, you can see that in this survey. For sentence level, it's the same. There's a lot of research focus on using deep learning for sentiment analysis. Here is some hybrid model. Yes. And in the expect level sentiment classification is the same. There are a lot of to apply deep learning for the aspect level sentiment classification, expect adjacent and categorization. Yes, this is how I should talk about the methodology for sentiment analysis with two important. The first is the work embedding, and the second is the deep learning approach. Deep learning. Next step, I will show some case study from my research. The first research, my research is domain specific where general purpose work representation in sentiment analysis for deep learning model by Onimi Bu Thanh Hung in 2019. And in this research, we apply deep learning model with the four deep learning model for sentiment analysis: CNN, LSTM, hybrid CNN, LSTM, and by LSTM to sentiment analysis. And we apply different work representations, domain specific and general purpose work embedding. And we select the optimal solution with each model for the sentiment analysis problem, so that we have 16 model for sentiment analysis, because we apply to the two domain specific and general purpose work embedding. That's why we have the 16 model. From the data, we data from the VLSP, and we do pre-processing and tokenize and not tokenize. We use the work embedding with the two types, domain specific and the work embedding with the fast track from the Facebook AI research. And we apply the four deep learning model. That's why we have 16. The data we use from we apply for Vietnamese language. We collect data from the 50.pm with the PT common, PT positive and PT negative. And here is more detail about the data. We divide the data to type, chain, and validation with the size as shown in this slide. If we analyze this more detail about this data, we can see that more detail about this data set. And we use the beautiful soup for pre-processing and tokenized by the Vietnamese top group. Labor Jet 2018. We do explaining to approach, not tokenized, and domain specific with the embedding layer of Kerat, and the second is a perfect, so that we have the 16 model. We use Kerat and TensorFlow framework. Here is some parameter model in this research with the CNN, LSTM, and by LSTM. And you can see that the most time is by LSTM. which is stand for East Airport, and the plastic is the CNN, and hybrid is the second position. The time is very important if we use the application because you know that the time is very important if we use the upper application, and we evaluate by the accuracy by this score, and we get the result here. We had 14 more 16 model, yeah, so 16 model, and for the domain and for the general with the fast tag, and here it means that not tokenized and tokenized. Because you know that in Vietnamese language, sometimes tokenized is affected to the result, and we want to mining the tokenized is affecting to the result or not. That's why we apply in the two ways. The first is the tokenized, and the second is not tokenized. Yes, not tokenized, tokenized. And here in you can see the column and the row, the row, the row. Here is the best model in the column. Yes, not tokenized with the domain specific. Yeah, for tokenized CNN. And for the row, the CNN is well in this. Yes, you can see that the bad result in the column and row. And the second research here is integrating sentiment analysis in the recommender system is the public in reliability and statistical computing. Yes. And in this research, we apply sentiment analysis to the recommender system, and we use the hybrid deep learning approach. You know about the recommender system. In the recommender system, we use the matching factorization model, and from the sentiment analysis, we get the probability of a sentence. From the probability, we can count the number score to, and from the number score we can we recommend to the product. Here's more detail about recommender system, but we don't focus on recommender system because this talk I only talk about the sentiment analysis. And we had two master students, one graduate in last year, and another will graduate in this year, and we have some undergraduate students. We did with one project, and we had 1, 2, 3, 4, 3 papers. Yes. And here I will give them a small demo, and you can know just how in the first research. In the first research, we apply to two approaches. The first year, domain specific and general specific with the four model, LSTM, CNN, LSTM, and by LSTM. But wait a minute. Yes, take a look about the research. Yay, you see that. Okay, and now you can see that we have the four model, CNN, LSTM, CNN, LSTM, and by LSTM. And to build the web app. Yes, and here is a data analysis. Yeah, you can see it's a Vietnamese, so that I will explain. Yeah, it's more detail about the data we use. Yeah, and the method we analyze uh, yeah, the four methods: CNN, LSTM, CNN, LSTM, and by LSTM. And you can see that the result in instrument method. And it use some, for example, CNN. You can see the result here with the accuracy and confusion margin score. For the ILSTM, it's the same. It's you can see the result of the system. And we use a small demo here. Yeah. And for example, in this Vietnamese language. It means that the restaurant is a delicious restaurant, is a good restaurant. It is a good restaurant. And for example, can you see the read down here? Yeah, it's positive with the number here. Yes. Okay, that's a small demo to know that how we apply the deep learning for the sentiment analysis. And we just talk about the deep learning approach for sentiment analysis. The last week conclusion, I will talk about the introduction, approach, methodology, and some case study. And now I will give conclusion. For this presentation, I use the three main paper here, Sentiment Analysis Urban and Application Survey 2014, a short overview on sentiment analysis 2016, and deep learning for sentiment analysis survey yang tahun 2018. And the last here is I want to introduce about the RAI conference in our university in the next year. The State International Conference on Research in Intelligence and Computing in the Engineering. This means that we conference from the India, not from the Vietnam, and we collaborate with the other in the India to organize this conference. And here is some more detail. You can check more detail in the website here. RAI.in. Thank you for your listening, and I hope you will give me some questions to discuss more how we apply deep learning approach for the sentiment analysis.
Thank you, Professor Thanh. The presentation was quite thought-provoking and insightful. So I think all the participants, those who are working in sentiment analysis or opinion mining, have got lot of information about not only about the software on deep learning analysis, but the basic, I mean the methodologies, what we how they are being applied, and what are the advantages, and which one is doing better. Some kind of comparison also very nicely Professor Hong explained. So I think all of you, all the participants, particularly those who are working in this area, will definitely be benefited and to, I mean, pursue their research in this area. Thank you, Professor, for
Okay.
kindly agreeing to present this lecture. Thank you, sir.
Yes, and do you have any question? Yeah.
Okay, so let me. Yes,
Our
what
translation
question is
level.
here? Do we have corpora which are translatable? I mean, bilingual corporal are available or not?
Yes, um, when I studied in Japan, I researched about the machine translation. However, however, in this series, I only talk about the sentiment analysis, and it means that we don't use the bilingual for the sentiment analysis.
So one more question:
Yes,
how augmented learning will be useful for edges?
augmented learning, augmented learning.
Yes,
Yes, augmented,
augmented learning.
augmented
How it will
learning.
be useful to mobile agents?
As I know in the first line. Actually, sentiment analysis apply in the many applications, many applications. Uh, when you search in the Google product search, you can see that here is the sentence about this picture, and from that we want to know is the positive. For example, for symbol sentiment analysis is the positive or negative. If we know that it's positive, positive. And the customer can know this camera is a good picture or the good picture, the good zoom or design, yes, something like that. And from that, the customer will choose the good camera for them. And your question asked me about how augmenting learning will be useful to the mobile even.
Yeah.
I think that how can I answer the question? How augmentation learning. Could you explain, Subrat, could you explain more detail augmented learning? Because you discussed about mobile agent. Yes, that's right.
Hello.
Yes. Extracting data from social side and analyzing it can give the insight to effect of corona. Yes, and now sorry Surat para uh, maybe I will discuss with you later how augmented learning will be used soon with the mobile again. Yes, and for the stream mana lainnya can we get how we can win corona with the
Yes.
sentiment analysis. Okay.
And
Uh, Sentiment analysis is one topic of the natural language processing. And for the corona with the sentiment analysis, depend your purpose and your data. For example, you collect the data from social network in the each day, in the each province. Yes, And you want to know um, the people talk about corona with the positive or negative. Yes, and from that we uh, with the positive and negative we had the secretary for the sick province. I think that is the sentiment analysis is suitable for the big group, for the big company, not for the small company. It means that the data collection from the big company is good for the sentiment analysis. For example, for the Facebook, for the YouTube, for another big company, it has a big data, and from big data, it can use the sentiment analysis to know more detail about how customer think about your product. Yes, that's what I want to know. That's what I want to say. Okay, prediction and solution of corona prevention using sentiment analysis. Yes. Okay. Thank you.
Hello, sir.
Yes.
Myself, Dr. Inga.
Mm-hmm.
I only asked you the question, the prediction and the solution of the COVID-19, and that is the corona, using your sentiment analysis.
Yes. Yes, you can do that, but
Yeah.
depend on your data collection.
But one
Yes.
thing, sir, are you listening me, sir? But one thing,
Yes.
by day, there
Content.
is a dynamic variation in the growth of the corona. Okay.
Yes.
By day, there is a variation of the growth
Mm-hmm.
of the corona. That is the increase of the corona. It is based
Mm-hmm.
on the various parameters.
Yes.
That is the
I think we can do that. We can do that.
yeah.
However, in the as I told you in the first step, let's check it out.
Mhm.
Yeah.
The,
We have the three
Sorry.
level. The first is document level, the
Mhm.
second is sentence level, and the
Mhm.
last is aspect level.
Mhm.
And how about the document level? Here is three level, you know,
Mhm.
and
Mhm.
depend on data you collect. You will apply for the document, or sentence, or aspect level.
Mhm. But sir,
Okay.
one small request, that any disease or any roamer analysis is there, right? You know that there is an analysis, a mathematical modeling for rumor
Roma, yes,
analysis.
yeah, yeah.
Okay,
Ah, yeah,
so
yeah.
I think we can
Linguistically
apply
very
that here.
important. Yes.
Uh,
I think when I talk about the yeah.
and
For example, in the past,
yeah,
you
ne-
had programming for 150 language.
uh,
Yes, and I don't know Indian language include English or not. Please check in the past, like they supply with 150 language.
okay.
And another uh, so that the linguistic is very important. I think Indian is the biggest country in the world, and so that you must develop some tool for pre-processing language. For example, tokenize, uh, chunking, uh, back of work. Yes, yes, something like that. Yes. Another question is about the uh, face picture identification is emotion from email. Yes, face picture. But face picture is more related to the email processing, not language processing. Yes. So that in the picture you can use the facial emotion recognition, and uh, I do some research to the facial recognition, but almost we use the technical for the image processing, not for natural language processing. It could be yes, it could be why reinforcement learning is not used in the sentiment analysis. Okay, why reinforcement learning is not useful. Let's take a look about the reinforcement learning. If you want to use reinforcement learning, you have to now take a look about the reinforcement learning. Yeah. Here the reinforcement learning, you have an event, you has the state and environment, and from that we after you will reward, you will change you can modify the action to suitable to the environment and reward. And deep reinforcement learning. Here is the reinforcement learning. You can see reinforcement learning, and here the deep reinforcement learning. And your question is why deep reinforcement learning is not suitable for the U2B viewer. Actually, I only talk about the sentiment analysis, not the not the. I think that I thought that the reinforcement learning is not suitable for the sentiment analysis, but another problem of natural language processing, we need reinforcement learning. Installation, you can use the reinforcement learning, or some another type of natural language processing, we use the deep reinforcement. Yes. But for sentiment analysis, we don't use the reinforcement learning. Maybe reinforcement not that without other, so that we use the other deep learning plot for the sentiment analysis. Rumor analysis. Yes. And few most useful Python library to get emotion sentiment person from Mumbai. Okay. But is the not included in this presentation. So you asked about the email processing. However, when you check my site, yes, I do some research related to the email processing. For example, here you get facial expression recognition with the CNN and yes. And in this research, we use CNN to check the spatial picture and LSTM to classify facial innocence. And for library, you can use, for example, Keras or TensorFlow or PyTorch, some library like that. And in our research, we use the Keras, yes, in Kuna. Okay, I think I answered all the questions here. And do you have any questions?
So I think there is no other question left for you. Thank you, Professor Thanh. Thank you.
Okay, thank you very much.
Presenting good lecture. And we hope this will be helpful for all the judges and also the students who are doing their masters or PhD, particularly masters and the postdoc students, those who work deep. I mean, those who are interested to go into deep of this particular sentiment analysis field. Thank
Yeah,
you.
thank
Thank you.
you. Thank you for the question. Yeah. Okay.
So
Good night,
let
everyone.
me
And
announce.
see you. Yeah.
So tomorrow again we will start our second session,
Sure.
day two and day two session exactly at 9 a.m. And the topic is financial application of machine learning. And the speaker is Professor Rupa Tulsiram from University of Manitoba, Canada. So I hope all of you will join and enjoy this particular lecture. Thank you
Surely,
for joining
surely
us.
we will join. Surely we will join. Yes, surely.
Okay, thank you. Thank you.
Very, very, very good
So,
lectures. Very good lectures.
okay, thank you. So now
Yes.
we will wind up our second session, today's second session. Thank you, Professor Han,
Yeah, yeah,
and
yeah.
thank
Thank
you
you
all
very
the
much. Yeah,
participants.
welcome. Yeah.
Thank you.
See you. Yeah. See you, everyone.
Okay.
Okay, I will send the slide to everyone soon. Yeah. Yeah.
Yes, sir. Yes, sir. Hmm.